Hi, my name is Jeff Rideout from Memorial University. I'm here today to tell you about Matlab, introduce you to some Matlab essentials. Matlab, very widely used program in academia and industry. Very high usage rate, very low rate of people complaining about it. My personal opinion is that it's just awesome. Hopefully I'll give you a taste of that. I'm going to start out in this video by introducing Matlab as a really fancy calculator. And that'll set the stage for some of the later videos where you'll be writing programs that execute scripts of some of the Matlab commands. So what we see right here when you open Matlab, this is the command window. Okay, and we'll see this double right arrow prompt. You're going to want to maybe draw files from and store them in a directory. So up here we have some little icons. If you hover over them, you'll see what they do. I'm going to browse for a folder where my files are located. Here's the standard Windows 10 browsing window. I've got a folder called Matlab Tutorial, which I've selected. If you're old school and maybe you used something that, something called a VAX machine back in the dark ages, some of the command line commands that you can use if you want to avoid the icons will let you see, for example, what is your present working directory. pwd, here's the path to the directory that I'm in. All right. If I want to list the files, I can do an ls. Okay, this is some old school stuff. Now, if you want to change the current folder, you just use the easiest way is just to use the little buttons there. Now, so the first thing I want to get into is I'm going to use some variables and matrices, and we're going to solve some linear equations. Now, there's a document that accompanies this video, which you can download in a link in the description below. All right. So suppose you have two linear equations. I'm going to bring in another document here. This is the document that you can follow along with on your own. So two linear equations, 3u plus 2v equals 9, minus 5u plus 7v equals minus 2. All right, we can write those equations in a matrix vector form. All right, so look at this little matrix equation here. You multiply out this matrix. It says 3 times u plus 2 times v equals 9, minus 5 times u plus 7 times v equals minus 2. If you wanted to solve these equations in a linear algebra course, you would invert this coefficient matrix, 3, 2, minus 5, 7. You would multiply both sides of the equation by the inverse of that matrix. So this equation's in the form coefficient matrix A times a vector of unknowns x equals b, which is a vector of sort of right-hand sides. If I do A inverse times b, then I should get the value of the x vector, the first element of which will be u and the second element of which will be v. So I'm going to go to my Matlab command window, and I'm simply going to, well, first I'm going to increase the size of the font here. So under Home, let's see here, looking for Preferences. Here we go, Preferences. So you can go through this and you can see all the different things that you can tweak. I'm going to crank up the font size to 12. We'll see how that goes. All right. Maybe I can also make that bold. Monospaced, bold. Okay. There we go, that's better. All right, so I've got an A matrix. A equals. So to declare a variable, I just type in A equals, sort of like a fancy calculator. If I want to define a matrix, well, if I wanted to define a scalar, I could say A equals 3. And we can see here that if I want to do A squared, I can do A times A. Now you can see it. There's a second variable over here called ants, which is the answer that I just got from Matlab. Now the ants variable has been updated to 9. I could do ants, which is 9, times A, which would be 9 times 3, 27. A plus A. All right, basic calculator stuff. Now going back to my matrix vector equation example, I want to put A in as a matrix. I need a square bracket. Now the format in Matlab is, the first row of my matrix was 3 and 2, so I type 3 space 2. When I want to define a new row, put in a semicolon. Semicolon tells me that the next two entries will be the second row, minus 5, 7. Now, I see A as a 2 by 2 matrix. It doesn't give me the brackets, but that's okay. Now I need to define the B matrix. So I'll go B equals. Now that's 9 in the first row and minus 2 in the second row. Once again, going back to this example. Okay, B is 9 minus 2. There it is. Okay. And if I want to find the vector of unknowns, x equals, I want to do the inverse of the A matrix. So I can just do inv A. And then I want to multiply that by the B matrix. All right, so those two elements of the x vector, if I want to extract the first element, I got x1. First element of the x vector is 2.1613. Second element is the 1.2581. So the first element of x is u, and the second element of x is v. All right, so I can solve linear equations. It doesn't have to be 2 by 2. It can be anything by anything. I can also do a to the power of minus 1 and get the inverse of a. And that should be the same thing as inv A, and it is. Wonderful. All right. If I wanted to take my x vector and assign the first element to the variable u, I could just say u is x1, and v is equal to x2. You can see over here on the lower left panel, there's a list of variables that is constantly updated. Okay, so it gives you the name of the variable and its value. If you wanted to get a list of the variables in memory another way, you can type whos, W-H-O-S. There it tells you the variable name and its size. Some of these are matrices, 2 by 2. Some of them are scalars, which is a 1 by 1 matrix. It tells you the number of bytes and then the fact that these are double precision. If I ever want to clear a variable, on your calculator, you got a C button, which either clears the last entry or it clears everything. If I just want to clear the u variable, I can type clear u. U is now no longer in my list of variables. And if I type u, I get nothing. Right? If I want to clear all variables from memory, I clear all. If you're entering a lot of commands, maybe you want to go back and re-enter a command that you entered a few minutes ago. So if you hit the up arrow, that's going to scroll back through all the commands that you have entered. So if I wanted to re-enter the u equals x element 1, I can just go back and do that. Oh, I just cleared all my variables, didn't I? Oh yeah, so I would have to go back in here and redefine the A matrix, and redefine the B matrix, and redo the x equals inverse A times B. Now I can assign the variable u. All right, so you can do that. If you've got a matrix variable or a vector and you want to know the size, type size of, enter variable name. A is 2 by 2. B is 2 by 1, and as is customary, first number is the rows and the second number is the columns. Okay. If you ever want to get help with a command, you can type help and then the command name, or you can go to the excellent help. There's help built into the software, and there's also a very vigorous online help community. If I type help inv, it's going to give me everything I wanted to know and maybe even more about the inverse command. It'll tell you how to enter the arguments. It'll tell you the syntax of entering the command, and it'll also take you to more documentation if you want. All right, so there's lots of help out there. All right, what do we have in our memory? We have, oops, oh yeah, I entered in who's x by accident, and it recognized that I might mean who's, which I do. It's very handy when you are building up matrix and array variables. Sometimes you want to extract a part of a matrix or an array. Suppose I was interested in the first row of the A matrix. The A matrix was this, and suppose I want to define a variable row 1, which is the first row, which is simply 3 and 2. I want a part of the A matrix. Specifically, I want 1, 1 and 1, 2. So basically, I want 1, everything. If I put in a colon, then it'll give me 1, everything. So there it is. All right, I can find the first column of A. I want 1, 1 and 2, 1. I want everything, 1. So here's the first column. It automatically allocates space to expand variables if that's what you need to do. You can sort of string matrices together to make a bigger matrix. I could say I want to define a new matrix A, which consists of the original matrix, so that'll be a 2 by 2 subset of this variable, space, and let's say I want to add in 2 times A. What I should get now is a 2 by 2 block for the first A matrix, and then another 2 by 2 block, which is twice the A matrix. So there it is, 3, 2 minus 5, 7, and then twice that. And if I hit the up arrow, I can go back here and I could add the square of the matrix. This is one other thing I'll mention here before I wrap up this introduction to the command window and variables. A squared, as you could imagine, is a matrix multiplication of matrix A with itself. Let me see here. Now I want to put those two matrices side by side on the screen. If I was going to multiply these matrices together, I'd do 3 times 3 plus 2 times minus 5. That's the first entry. And I would do 3 times 2 plus 2 times 7 as the second entry, and so on. If I wanted to simply square each individual element of A, so if I wanted this to turn into 3 squared, 2 squared, minus 5 squared, and 7 squared, then I would not want to do a matrix multiplication. I would want to do an element by element squaring operation. The point, the period, will let me do that. If I do A point times A, I will take each individual element of A and multiply it by itself and throw it in the matrix. So here I get each individual element squared. And if I take ants, which is that matrix I just got when I did my previous calculation, if I do ants point divided by A, I should be dividing the 9 by the 3, the 4 by the 2, and I should get back my original A matrix. All right, so now we have some comfort with manipulating variables, even matrices and vectors. So now we're ready to write a program to execute multiple commands in a scripted way.